Ladies and gentlemen, good afternoon. It's great to be back in Hong Kong, and it's a pleasure to be here with you today. Today I have the honor of being joined by two astute professionals in their respective fields, Dr. Siad Ma of Expedera and Dr. and Professor Wang Xiaogang of SenseTime. Welcome, gentlemen.
Thank you.
Thank you.
So today our discussion will be around edge computing and how it's becoming a key driver of AI innovation today. For those of you in our audience who are not too familiar with edge computing, it can basically be described as deploying compute and storage resources closer to a data source, which in turn makes systems more scalable, data processing faster, more reliable with better security. So we're here today to talk about some of these trends, as well as discuss some of the technical difficulties facing the industry in terms of adoption and deployment. So gentlemen, jumping right in, the first question is for the both of you. I will start with you, Professor Wang. Okay. Please tell us a little bit about your background and how your company, SenseTime, is helping to advance AI on the edge.
Okay. So SenseTime is an AI platform company. It was established in 2014. At that time, we were the first time for face recognition surpassing the human eyes performance. And that's the first time the AI is surpassing the industry red line. And then we have the application on both the cloud and the edge side. In particular, for the edge side, we have AI application for the mobile phones at the era of AI 1.0. And for example, the face unlock. And we notice like Xiaomi, Oppo, Huawei all use our face unlock function. Also using the, we also develop an AI model for the imaging photography and mobile phone, or also the super night to generate the videos. And actually, in the past several years already, billions of mobile phones have our AI function. Now, we are also shifted from the mobile phone to automotive business. You know, nowadays the smart vehicles, they have a lot, it's a focus and have a lot of AI functions. We work on the autonomous driving and the smart cabin, and we put the model inside the car, and to have the end-to-end solution for autonomous driving, and also use a large model, multimodality model to change the human-machine interaction. Yeah, these are two major areas. So far, for automotive business, we have already have over 4 million cars on the market with our AI function. And looking forward in the future, we have many of the technology can be applied to robotics. And that's kind of a roadmap for us.
Thank you. Siad, same question to you. Tell us a little bit about yourself and how Expedera is helping to bring innovation to AI on the edge.
Yeah, so Expedera is an AI hardware company that makes neural processing units, which is what we call
NPUs.
AI accelerator. And that's a piece of hardware that you put on the chip that makes you process AI models faster. And we've been around for over 6 years now. And it's very interesting that our progression is similar to what Dr. Wang has. We started going into smartphones. We're in tens of millions of smartphones already. And applications there like low light video and enhancing denoising, and also some of the enhancing of the picture quality. All that is in the smartphone these days. And then the next thing we went into is the auto industry. So autonomous driving is our next thing that we just went into. And then we're moving to AR, VR, and also LLM at the same time. So yes, it's very similar. I think it's because the whole industry is shifting from smartphone taking the lead into automotive and now into LLM and the cloud. Yes.
Okay, so Siad, sticking with you, could you please define edge computing for us and tell the audience how edge computing differs from cloud computing? I mean, doing something like machine learning locally instead of having to rely on the cloud can be a huge advantage, but if consumers are using it, they still opt for the cloud because of cost savings.
Yes. So I think the definition is that you're making all the processing of your AI model at your local place without internet connection, without connecting to a data center or the cloud. And that's the definition of an edge computing. It could be as simple as a smartphone where you don't have any connection. So sometimes you lose your Wi-Fi connection, you use your cellular connection, but you still want some of the features to work. For instance, your face, you want to make sure your face still recognizes your face and you can unlock your phone. Other things like you know, some of the applications locally that you want to do, but it depends on AI, you still want to do working without connectivity. And then you have something like self-driving. Your car has to work and make sure you can detect all these objects even if you lose connection, because that's a safety hazard, right? So things like privacy and safety is very important to be able to process everything in the edge without going to the cloud. And of course, there's latency questions and all that stuff that is embedded in that, and cost saving and stuff like that. But to enable that, you need the proper hardware as well as software to make sure everything can run smoothly and have a good experience, user experience in the edge.
So the edge is already impacting specific industries like smart manufacturing, agri-tech, auto retail, and of course, autonomous robots and vehicles. Professor Wang, can you give the audience some real-world application cases of edge computing?
Oh yes, probably I can. I already mentioned a little bit, but now probably I can focus on using kind of an intelligent vehicle as an example. For example, autonomous driving, because you know, because of the safety, it requires very short latency and the security, and so it must run locally. And traditionally, this autonomous driving system has many components. For example, perception, positioning, fusion, planning, and control. Many modules. A lot of modules rely on the human engineers to write the rules. But with the emergence of a large model, nowadays people provide the end-to-end solution. Basically, they use a single model to replace many different modules. And this model is driven by data. We collect a huge amount of data which can cover many corner cases and can have the driving behavior like a human. So this is really in 2022, and we're the first time, we're the first one provide, we call this an end-to-end solution for autonomous driving. And nowadays, you can see a lot of OEM, even Tesla, they announced that they use the end-to-end model for this mass production. And besides the end-to-end model, it also nowadays people also use multimodality model for the autonomous driving, because a lot of complicated traffic scenarios is like a human brain. You need to do the reasoning. You need to figure out how to drive, and this multimodality large model can function like this. So end-to-end plus in multimodality model, this like the AGI for autonomous driving. And another important application area for smart vehicle is inside the cabin. So we can use a multimodality model to improve the human-machine interaction. And previously, you know, this some company work on the speech recognition, like sometimes we work on the computer vision. But with the emergence of the multimodality model, so one model simultaneously receives the image videos, the audio, different types of signals, and give the response. And it really behave like a human. So previously we treat this as a tool or as an assistant. Now this robot inside the car really like a family member, and have a strong emotion connection with the passengers and the drivers, and had the memory, can keep watching. but you rely on the running, always on, running on the device side. And that's kind of, I think, emerging application for large model on the edge side. Yeah.
So as with any high growth industry, the edge also faces challenges such as bandwidth, congestion, latency. Siad, could you tell the audience a little bit more about the technical difficulties that the industry is facing?
Yeah, I think the main difficulties we see that people are trying to solve is how to minimize power consumption. Obviously, your smartphone.
Which is something you're focused on.
Of course. Our the basically Expedera, the main selling point is we have the best power performance and efficiency in the industry for MPUs, and that's how we got into smartphones. And as you know, you don't want your smartphone. You open your AI application and 10 minutes later your battery is dead. So power efficiency is very, very important. Same thing for car. You don't want to carry a big battery pack and charge it in every half hour. So power efficiency is very important. That's the problem that we're trying to solve. Most of the previous hardware like GPUs is not very efficient. It's not tailored specifically to run AI models. So that's what we're trying to optimize. The other problems that we see nowadays is that you see new models evolving very fast. Before we see like one revolution of a model every year, maybe 2 years, and then became like every 6 months you see a new model, especially when you saw these LLM coming up, ChatGPT, what's that? Now we see like every month or even 2 weeks you see something new. So the whole cycle of new models coming up gives us a lot of challenge to keep up with the industry and saying, I need to be able to run all these models and make sure that my whatever MPU I put on a hardware is still applicable when it actually goes into production. So that's a big challenge, and that's everybody is facing that challenge to make sure it's future-proof.
Professor Wang, your thoughts on technical challenges facing the industry?
Oh yes, just mention that especially with the emergence of the large model and the computation power and the bandwidth, but we can also see, I think it's quite important to for the co-design of the hardware and the software, even the models. For example, recently we can see the DeepSeek use MOE, mixture of expert architecture, and you can save a lot of bandwidth, the memory, and also computation power. Because every time you only need to activate part of the neurons and to pass certain part of the parameters. And this gave us the kind of promising direction for the AI on the edge side. In the meanwhile, we may also want to need this design of the chips, the hardware, which can better fit the model. And I think another challenge is probably the ecosystem, because on the cloud side, we can see that probably everyone kind of, for example, the NVIDIA is dominant. They have the CUDA system, economic system. But on the edge side, we have people have the different chips, and so when you deploy your model on the chips, it depends on the accuracy of the quantization, and you need the specific tools, and so the software, the ecosystem is also quite important. Should be very convenient for the developers to deploy the AI model on the edge.
So one of the main benefits of Edge is that it's adaptive and it's proactive. Siad, could you tell the audience about the growth trends and business opportunities in the edge computing market?
I think everybody sense that your life has changed over the last year. So it's no surprise, like everybody, I'm pretty sure in the audience, everybody has tried ChatGPT, downloaded the app on the phone, tried, maybe not extensively, but some people are actually using it every day, either for work or for asking questions. And solving their own problem. Students today don't need to study, I guess. They just use ChatGPT to do their homework. It's good and bad. Of course, I'm not commenting on that part. But it's already embedded in our lives. I think last year, this time, we're still everywhere discussing how we're going to use this technology. But as a parent, it is going to be everywhere. Today, however, your ChatGPT is all run in the cloud. It's not on your phone. So the next trend is, how can I take that model and totally decouple reliance on the cloud, and all the questions that you ask today is not going into the cloud and stored over there, and everything is customized to your own questions and answers. So that's one trend I see that is going to be important.
That's well said, Sia. That's
Yes.
exactly what I think the audience is looking to hear.
Yes. Yeah. So the other trend I see is like software is evolving a lot faster. I mean, when I say software, I'm talking about the models. You see these AI models evolving a lot faster than the hardware can keep up. If you see what hardware does, is like we're still saying, oh, NVIDIA GPU. The next generation NVIDIA GPU is just more compute tops and more memory bandwidth. But what's the innovation? There's not a lot of change in that regard. Whereas when you look at the AI models, it's evolving to new applications. Suddenly I have this MOE that like Professor Wong mentioned, and always different ways of models, like training the models and usage of the models. So hardware is not keeping up with this trend. What I see is that we need a whole new method of processing these new models, and it's a chicken and egg problem, because without this hardware, you really can't get better models, and without the better models, you won't pitch the hardware to change. So remember when we first started AI, this AR trend is because of GPUs. Professor Hinton and the team used GPUs, and suddenly it opened up everything. Now, we have GPUs in the cloud, and NVIDIA making big data centers to process all this stuff. So I think the data center at some point is going to be, saturated at a point that we cannot advance more if we don't change the whole computing paradigm. I think that's the future that I want to look at.
Well said, Sia. Dr. Wong, could you tell the audience about how edge computing could transform daily life and what breakthroughs you potentially foresee?
Oh yeah, so I think we can see there are two trends. One is now the edge computing power is become bigger and bigger, and so now, for example, NVIDIA Sourcy has 1,000 TOPS, and we can put a lot of large model inside on the chips. So this is not only about autonomous driving models, also the in-cabin applications. So with this kind of new hardware, the chips, we can see the integration of autonomous driving and the in-cabin solutions. So the better coordination of the machine driving and the human behavior inside the car, and also we can see this as I said, is moving. Initially we apply this to mobile phone, and now to the vehicle. But we can see in the future, a lot of these techniques will be applied to robotics, because of this robotics and the smart vehicle, they have a lot of overlap on technology, hardware pipeline, etc. So in the future, we can see that different types of robotics and in our daily life on the factory to improve this productivity significantly. And also we can see another trend is we can see this model will become smaller and smaller, and can be, for example, can be put inside the sensor. You know that the sensor is very small. Initially, the sensor is only for sensing the pixels, and then people have the two layer of the sensors. The one layer is for the digital computing. Now we can see these have the three layers of sensors. That one is for the AI engine. It's a three-layer structure to make really make the model put everywhere. So with that technology, you can have the millions of even more sensors everywhere. So we can see the AI can significantly transform our daily life.
So gentlemen, the last question is final thoughts on where the industry is headed.
Yeah. So I think this with the improvement of the AI is we are moving from the traditional AI. So the AI can only solve the particular problems. And so for such time in the past several years, we deliver as 40,000 models for different application tasks. Now we are moving towards the AGI, artificial general intelligence. One model can really solve, can be applied to different scenario, and it can really behavior like a human. And so it will from the vehicles to the robotics, and so have the emotion of the AI, and so really have the closer connection, dependence with everyone, our daily life, and we also can see with the faster growing of the AI software, the AI models, we also improve pushing the hardware development. So to better integrate both, and that's be the direction. Yeah.
Siad, final thoughts.
Yeah, I totally agree with Professor Wang. Just like how everybody today cannot live without your smartphone, tomorrow you cannot live without AI. So we're gonna have a world where AI is personal to you, it's your best friend. So.
Thank you, gentlemen. Appreciate your time. Appreciate your knowledge.